Hi, and welcome to Unit 2, Lecture 2 for Intro to Logic. We're picking up where we left off with derivations. Remember, derivations are ways of breaking down the reasoning behind an argument into simple steps, each of which is obviously valid. Each of these simple steps has to follow a certain rule we call inference rules. Last time we learned two of these inference rules, arrow out and wedge out. So arrow out is over here. It's when you have an arrow statement, A arrow C, and you have A, you get C, or if you have an arrow statement A arrow C, and you have the negation of the then part, not C, the negation of the if part, not A. The first form is called modus ponens, the second form is called modus tollens. The other simple inference rule we learned last time is wedge out. If you have A or B, not A, you get B. A or B, not B, you get A. So if you have an or statement, you know one of the two sides is not true, you know the other side has to be true. These are out rules. They're rules for using or breaking up a statement that has a certain main operator. So arrow out is a rule for using or breaking up a statement whose main operator is an arrow. Wedge out is a rule for using or breaking up a statement whose main operator is an or. So we divide our rules into two categories. Out rules are rules for breaking up or using a certain kind of statement. But we're also going to have in rules, which are rules for getting or making a statement with a certain kind of main operator. So here are the rules we're going to learn today. We're going to learn a bunch of new rules today, and we'll walk through them one by one. So the first one is ampersand or and out. If you have an and statement, A and B, you know A is true. Other form, if you know A and B is true, you know B is true. You can get either of the two sides of the and statement on a line by itself if you have an and statement. So they're both true, then either one of the sides by itself is true. The opposite of this, a rule not for using or breaking up an and statement, but for making an and statement, is ampersand in or and in. If you have A on one line and B on another line, you can put them together to get A and B on a line together. We also have rules in both directions for the two-way arrow. If you have the two-way arrow, A double arrow B, from that you can get A arrow B. If you have A double arrow B, you can also get B arrow A. You can change the two-way arrow into a one-way arrow in either direction. If you have the one-way arrow in both directions, you can use ampersand in. If you have A arrow B and you have B arrow A, you get A double arrow B. So that's an in rule because for that one, you're making a double arrow statement. Double arrow out, you're using a double arrow statement. There's also wedge in. If you know A or anything else, A or B. That B can be anything you want it to be. So if A is true, then A or anything else is true. If A is true, then anything else or A is true, B or A. So if you have half an or statement, you get the whole or statement. You don't need both halves, just one of the two halves. That's wedge in. Then we have the special rule called double negation. If you have A, you get not A. If you have not A, you get A. Now for all these rules, you apply them when these operators are the main operators. You only apply ampersand out when the ampersand is the main operator. You can also do this form of double negation when you have the double negatives as the main operator. If you have the other form of double negations become the main operator. So one of the two forms of double negation is an in rule, and one of them is an out rule. Let's do some derivations that use these rules. So let's look at this first one. So there's still direct derivation. We haven't learned anything else yet. So we'll write direct derivation by the show line. Click new line to get a new line. Now, if I want to use or break up line 1, I need to use modus ponens or modus tollens. I need to use arrow out. If I had F or G, I could get H and J. If I had not H and J, I could get not F or G. Now, I can't get not H and J, but is there a way to get F or G? Well, how do you get an or statement? You get it by or in. Can we get or in from something? I can get or in from 2. I have F. If you have half an or statement, you can get the whole or statement. This comes from line 2, wedge in. Now notice that for wedge in, I'm only going to write one line number over on the right because there's only one line, one statement above this line in the rule from what you have and what you get. You're only going to cite one line number in the result. So 2 wedge in gives me F or G. Now that I have F or G, I can use line 1. If F or G, then H and J. I get H and J. from 1 and 4 modus ponens are allowed. New line. I'm trying to show H by itself. I know both H and J are true, so I know something stronger than H by itself. If you have an and statement, you can take each half of it and put it in a line by itself. The only one we need here is H, so I'll put H in a line by itself. That comes from line 5, ampersand out. And again, ampersand out only uses one line number. So now I've shown H, I can cross off my show line and draw my box. Check my derivation. Okay? Let's do another one. If both A and B, then not C. A is true. Either D is true or C is true. If A is true, B is true. Show that both D and B are true. Again, this is direct derivation, so I write DD over here in this box. Click new line to put in a new line. Now, if I want to use line 1, I would need to have A and B. To get A and B, I need to have A on one line and B on another line. Where am I going to get B from? I have A already, but where does B come from? Well, B is going to come from line 4. Line 4 says if A is true, then B is true. I have A already, so I get B from 2 and 4 modus ponens are allowed. Now that I have A and B in separate lines, I can put A and B in a line together by ampersand in. If you have a statement on one line, another statement on another line, you can put them together and make an and statement with ampersand in. So lines 2 and 6, ampersand in uses two lines, the two lines you're putting together, ampersand in. Now I have what I need to use line 1. I have A and B. If A and B, then not C. I get not C. 1 and 7 modus ponens. Now I have what I need to use line 3. Line 3 is an or statement, so if I want to use it, I need to use wedge out. I have the negation of one of the two sides, I get the other side being true. So I have the negation of C, so I get D being true. By 3 and 8, wedge out. Now I have D on one line and B on another line. I'm going to put them together to get D and B. That's the conclusion. That's what I'm trying to show. So 6 and 9 put together give me D and B. That's ampersand in again. All right? See how that works? So I've shown what I was trying to show, so I can cross off the show and draw my box and check my derivation. Let's do one more here. Direct derivation. Whenever you get an and statement as one of your premises, probably the first thing you want to do is use ampersand out to break it into its two halves. So notice that line 1 is an and statement. The main operator is an and. So I can get each of the two halves on a line by itself. I get S arrow T, put that on a line by itself, 1 ampersand out. I can get the other half as well, U or W. Same line, same rule, just using the other version of the rule to get the other half of the and statement. So you have an and statement, you break it up into its two halves. Now I want to use line 6 and 7. Line 6 says if S were true, T would be true, but line 2 says that T isn't true. So I modus tollens now, I get that S isn't true. Right? That's 2 and 6. Modus tollens form of error allowed. Line 7 says either U is true or W is true, but 3 says U isn't true, so I get that W is true. That's from 7 and 3, wedge out. Now I have not S and W on separate lines. I'm going to put them together to get the if part of 4, right? I want not S and W together, so I get the if part of 4, so I can use 4. I have not S and I have W on separate lines. I can put them together by ampersand in. Then I can do my modus ponens on line 4. So quite often you'll use an in rule like ampersand in to give you what you need to set out an out rule. So I want to use the out rule on line 4. And now I can use the out rule on 4 because I used the in rule on 8 and 9 to give myself what I need to use the out rule on 4. So ampersand out, modus ponens will give me K. Oops. 4 and 10 ampersand, I wrote ampersand in, should be ampersand out. Gotta be careful. There we go. All right, let's do this one. So this one, we're trying to get a two-way arrow. The way you get a two-way arrow It's got each of the one-way arrows. So I'm going to want to get the one-way arrow in this direction, F arrow E, and the one-way arrow in this direction, E arrow F. When I get those two, I can put them together to make the two-way arrow. This is still direct derivation. If not D, then if F then E. I have not D at line 3, so I get if F then E from 1 and 3, arrow out. And also from F, E, then F, either if E then F or D, so I get if E then F, so I have not D again from line 3. 2 and 3 wedge out gives me if E then F. And I can put those two together to get E double arrow F. I have the F then going one way at line 5, the F then going the other way at line 6. So the rule there is double arrow in. You get the double arrow statement. Okay. Quite often you need to use double negation to set up an arrow out or a wedge out. Let's see how that works in this problem. Direct derivation. So I want to use wedge out on line 1. If either P, if and only P, or R is false, but I need to have the negation, the way wedge out works, the negation of one of the two sides of 1. The negation of the first side would be not in parentheses P double arrow Q. I don't have that. The negation of the other side would be not R. I don't have not R, but I do have R, for which I can get not R. So the first step in this is to double negate line 2. I can't do wedge out on 1 until I have the not R. I need the negation of one of the two sides. Now I have the negation of one of the two sides of line 1. So now I get P double arrow Q from 1 and 5 wedge out. Can't do the wedge out on 1 and 2. You need the negation of one of the two sides of the OR statement to do wedge out. Now I have the negation of it if I double negate the R at line 2. So now I have a two-way arrow. What do I do with the two-way arrow? The two-way arrow changes to a one-way arrow. I can change it to P arrow Q, and I can change it to Q arrow P. Which one does it make sense to change this into? You can do both if you're not sure. But I need Q arrow P here because I have Q at line 3, and I'm trying to get P. That's the conclusion. So I get Q arrow P from 6, double arrow out. I can then do modus ponens from 3 and 7 and get P. Arrow out. That's what I was trying to show. There we go. So the two-way arrow changes to a one-way arrow, and you want to think about which of the one-way arrows makes more sense to have by thinking about what you have and what you're trying to get. In this problem, we had Q, we were trying to get P, so we wanted the arrow to go from Q to P. All right, let's do one more. Sometimes it makes sense to strategize a little bit about what you have and what you're trying to get. This is still direct derivation. We're trying to get not if A then B. I could get not if A then B if I could get not C or D. How am I going to get not C or D? I get not C or D if I could get C or D. How am I going to get C or D? Well, I could get C by itself or D by itself. There's no C anywhere else, so I'm not going to get C, but if I could get D, I could get C or D. Where is D going to come from? It's going to come from line 2. So I need that two-way arrow. Now I have each of the one-way arrows. I just need to put them together. So E double arrow F, by putting together 3 and 4, double arrow in gives me the two-way arrow. Now I have what I need to use line 2. If E, if and only if F, then D, I get D. Sorry, this is not 2 and 4, it's 3 and 4. And this is 2 and 6, arrow out. Now again, from now I get C or D. If you have half an OR statement, you get the whole OR statement. So from D, I get C or D. That's 7 wedge in. It doesn't come from line 1. Line 1 is the reason I want it. It comes from line 7. If you have half an OR statement, you get the whole OR statement. Now I need to double negate that, because you need to have the exact negation of one of the right side to do modus tollens. I'm going to do modus tollens on line 1. I need the negation of the right side. The negation of the right side is a double negation since it already starts with a negation. So this comes from line 8. It doesn't come from line 1 again. I'm double negating line 8. Now that I have it, I can use line 1. I get not if A then B. If A then B, then not C or D, but I have not C or D. So by 1 and 9, arrow out, I get this. So I can cross out the word show. You can also click this to check the derivation. There we go. So that's it for today. We'll do some more. We'll learn a different kind of derivation, conditional derivation, in the next one.